Hi, everyone. Thanks for joining us. My name is Amanda DeFelice, and I'll be moderating today's webinar. Before we get started, just a reminder to post your questions in the Q&A section at the bottom of your screen, and we'll answer those at the end. Today's topic is maximizing hot word value with LLMs. And we chose this topic because we're seeing an explosion in LLMs that are really transforming how we interact with technology. And Sensory is the market leader in hot word technology. It is at the forefront of this shift. We've been pioneering the field of voice technology for years, and we're the first to achieve commercial success with wake words in Bluetooth headsets and mobile phones. Sensory solutions have been developed and shipped in hundreds of products, reaching billions of units worldwide. Sensory is the only company capable of developing and licensing wake words for tech giants like Google, Microsoft, Amazon, the Fruit Company, and Baidu. And their expertise extends across the broadest set of platforms, languages, and types of wake words. So with that, I'm excited to announce today's speakers. First up is Todd Moser. Todd is the founder and CEO of Sensory, which is his third startup. Todd's first startup went IPO, the second was acquired, and he's been running Sensory for 30 years now. He's written and received over 30 patents and has worked at the intersection of audio and technology forever. Next up is Ember Van Allen. Ember is the Senior Director of Speech Technology Development at Sensory. She has over 17 years of experience in speech recognition and language technologies and has applied her expertise to fields as diverse as consumer electronics, education, litigation support, and transit systems. Next is Grace Hines. Grace is Customer Services Manager at Sensory. She has a degree from the University of Maryland in linguistics and has spent the last 6 years at Sensory developing custom speech recognizers in the capacity of a product linguist. And finally, it's Jeff Rogers. Jeff is the VP of Sales and Marketing at Sensory. Jeff has been influential in the development and design of hundreds of products over the last 29 years that use Sensory speech and computer vision technologies. He has licensed speech and computer vision tech to companies such as Honda, Huawei, Lenovo, Microsoft, Panasonic Automotive, Samsung, Zoom, and many more. Panelists, thank you for your time today. Todd, I'll turn things over to you.
Thank you, Amanda, and thank you all for attending. Your being here really means that you already understand the high value of on-device wake words, so I won't talk a whole lot about that, but I will briefly talk about a few things and show you a really cool video. The video, it comes from OpenAI. It's probably the most widely watched large language model video that's come out. It was their introduction of ChatGPT 4.0. And what's really interesting about it, and we've condensed it down, I think it was half an hour or so originally, we've condensed it down to about a minute. And what we're going to showcase in it is the fact that they're saying hot words, even though the product doesn't really have one. So they're getting they're showing how convenient it is to use the hot words, but they're actually hitting buttons to turn it on and off. And at times they don't hit the right button and it interrupts them. So the real value of using these wake words is convenience. Button presses aren't required and there's a lot less interruptions. In fact, my personal use of a voice assistant is with Pi from Inflection. And I use Pi a lot as a resource when I'm talking with friends or family members and we have questions. I'll open up Pi and start talking to it and we'll answer the question. And if I don't immediately turn it off, it then starts interrupting us. So this interruption thing is a really big issue and you'll see it in the video. One final reason I'll mention of why you might want wake words is this concept of a mini marketing moment. And that's to get your brand out there and get people saying your brand over and over again. It's very, very powerful. So I've talked about why you want to use a wake word, but why use it on device? What's the value of on device? Well, power consumption is a big issue. Privacy is a big issue, and the bandwidth, if it's always listening and analyzing in a cloud, that's a lot of bandwidth happening all the time. In fact, Sensory's done some really interesting things to further enhance the privacy and the bandwidth issues by putting the speech to text on device. So we not only have the wake word on device, we have the speech to text on device. And what that ends up meaning is that you're sending 640 times less data to the cloud, 640 times less data by sending text instead of voice up to the cloud. And it makes it more private at the same time. So let's go ahead and watch the video. And what you're going to see is how naturally wake words come, and that when you don't have a wake words, it causes interruptions and isn't truly hands-free.
And if you see, there's this little icon on the bottom right of the ChatGPT app, and this will open up GPT-4o's audio capabilities. Hey, ChatGPT, I'm Mark. how are you? So I'm going to fire up another demo for that. Yeah. Hey, ChatGPT, how are you doing?
Okay, so let me boot up ChatGPT. Hey,
Cracks me
ChatGPT.
up how they're always hitting the
Okay,
buttons.
let me try again. So I'm going to breathe in deeply and then breathe out.
For 4, and then exhale slowly.
Yeah, well, I really appreciate all the help. So yeah, as we can see,
Wow, that's quite the outfit you've got on.
yeah, as we can see, we can chat in real time to ChatGPT, and not only that, we can interact with it with video as well.
All right, thanks, Todd. Ember, can we hand things over to you?
Yeah, thanks, Amanda. Thanks, Todd. So as you see in that video, there's a lot of button pushing. There's some awkwardness and some things happening that make it sort of a less natural, less easy to use experience. And so for an end-to-end speech-based interaction with an LLM, a hot word or a wake word is your starting point for a positive user experience. So now we're going to share some tips and insights for picking a phrase that will enhance rather than degrade that experience. In the end, remember that we're trying to achieve a complete start to finish, hands-free, speech-based, natural, and ultimately satisfying interaction that mimics how we talk to one another. So tip number 1, the hot word should be unique, but easy to remember and natural to say. We're looking for a word or phrase that is long enough for the technology to distinguish it from other speech and noise, yet short enough for the users to want to say it, to be able to say it easily and consistently. And so what we find time and time again is that 3 to 4 syllables is really the sweet spot. It is absolutely possible to have a successful wake word that is a little bit longer or a little bit shorter. And in fact, Sensory is one of the only companies to consistently pass the enhanced Siri test across languages for a short 2-syllable wake word. But generally, what we find is that 3 to 4 syllables in length is the best starting point when you're starting out. And if you're familiar with phonemes, you could also think of this as a minimum of 6 to 8 phonemes. Adding a salutation, those are become very common in hot words, is a great way to achieve that length of 3 to 4 syllables, but it can also help make the phrase unique and feel intentional to the users. And as you see, we have several examples of personality hot words like Siri and Alexa. It's a great idea to consider creating that personality for your product with a name that matches it. And that can also influence how an end user approaches their interaction, giving them cues to mimic natural human conversation in a way that's intuitive to the user. And as Todd mentioned, of course, incorporating your brand or product name into your hot word is great marketing. It can feel intuitive to the end user, and it can make it really easy for them to remember what the hot word is if it matches the product name. But you do need to bear in mind 2 potential pitfalls with this strategy. First, your users need to know how to say it. So you may need marketing efforts to educate your users how to say your brand or product name if you choose a hot word that people aren't already familiar with or isn't already words in their spoken language. And second, if you choose a hot word that people will naturally say when talking about your product, you may find it false firing. For example, a wake word of simply Google may false fire whenever people use it in conversation, either to talk about the company or to tell each other to Google something, or if it just occurs frequently in conversation. Now we'll go to tip 2. And we call this one adding acoustic secret sauce. So speech is inherently noisy and inconsistent. And linguists know that some speech sounds or phonemes can make a phrase louder, longer, or more distinct, or more consistent within a dialect and across speakers. And those are all factors that can improve performance. Remember that your speakers have different voices, different accents and pronunciations. They're closer or farther from the microphone. There are room acoustics, reverberation, things like that, that are all impacting sort of that acoustic signal. So on this slide, you can see some speech sounds that do the acoustic heavy lifting for us, like the voiced fricative Z, the Z sound at the beginning of Ziggy, or the affricate J in Genie. In contrast, think of the standalone H sound. It isn't very loud, and it doesn't sound very different from background noise like a fan or just other soft white noise or background noise. And then in the next bullet point, you see some examples of diphthongs or combined vowels. This is where you have essentially two vowel sounds smashed together into one syllable. These are also fantastic choices. Some examples in English are oi, o, and a. And finally, think about the sounds that may be more unique in your language that you're targeting. So for example, the j sound in English is not super common. So a word like genie may stand out a little bit from the background speech, the other speech that's happening in the environment, for if it's in that same language. In contrast, the schwa sound or is incredibly common in English and won't stand out significantly and be easy to distinguish from other speech in English that's happening. It's perfectly fine to have that sound in your wake word. It's common, it's going to come up, it's not an issue, but do make sure you have a variety of phonemes in your hot word phrase, a variety of different speech sounds to really optimize it and make it acoustically salient from the rest of the noise around you. Tip 3. Thank you. Our last tip is to consider your user, the use environment, and the relevant languages. So we're trying to find easy wins that help our user and help performance of the hot word. This also allows us to spend less time fine-tuning the model against avoidable pitfalls. So consider avoiding words with more than one common pronunciation if possible. The best hot word is one that's pronounced consistently across speakers and across dialects. This is your classic tomato example. In English, other example words might be caramel, caramel, or Celtic, Celtic, mischievous, mischievous, etc., etc. It can absolutely be done, but depending on how different those pronunciations are, you might have an easier time or achieve better performance if you just avoid those kinds of words in the first place. Similarly, avoid phrases that are reduced in length or change pronunciation significantly in fast or casual speech. For example, in English, how's it going? Or my all-time favorite US English sentence, I don't know, which sometimes becomes, I don't know. Obviously, we're not going to pick that as a hot word itself, but you can understand that language sometimes changes in casual and fast speech. Will your users know how to say it? Will they pronounce it the same way? Names and words that are borrowed from another language or that have tricky spelling may be pronounced very differently by different people. And then avoid phrases or words that may be common in the anticipated use environment. So a word like, a hot word like emergency or insurance might work really well on a beach or in a home. Do consider, though, if you're planning to have this product used in a healthcare setting, it may go off more often if those words are common in that usage environment. Or if, for example, you were the owner of a fitness app called Regal Fitness and you wanted to make a hot word just to allow a user to join a fitness class or something, and you decided on Hey Regal, keep in mind that you might be surprised to find near-sounding phrases. If the fitness instructors are frequently saying, here we go, it sounds pretty similar to Hey Regal. And lastly, avoid phrases that would be pronounced differently by non-native speakers in your demographic. For global products, choose a phrase that will be known by a large population via brand recognition, or common loanwords like computer, okay, TV. And of course, please do your homework. It's very important you find words and phrases that won't be embarrassing or offensive, not only in your target language, but in any language. This is particularly important for linguistically diverse demographics and global markets. And I have a few examples. There are many of these out there, but of some cases where things might have gone a little wrong. So ciao in Italian means hello or goodbye. It might be a great salutation to add to the front of your wake word, but it means only goodbye in Brazilian Portuguese. So if you're planning to release it to both markets, it wouldn't make sense for a user to initiate a conversation by saying goodbye. And ChatGPT in French sounds like ChatGPT, which means cat, I farted. It may be that your users have enough brand recognition that people will get over it and not worry about it. But this is something you would definitely want to know going into that choice. And lastly, there's a great reason why the Japanese sports drink karupisu or kalpis got rebranded as Calpico in North American markets for English speakers. And now I'll turn things over to Grace, who's going to discuss other ways to maximize performance.
Yeah. Okay, so my first bullet for maximizing performance, besides picking the best phrase, is on error rates. So this obviously really matters to the user, and it's what we're talking about when we talk about performance. Speech recognition is not accurate 100% of the time, just like an LLM and just like a human. And it's subject to two types of errors. So the first one that I have is false rejects, which I call FR. This occurs when a recognizer fails to detect the target word. The second error type is called a false accept, what I call FA, and this occurs when the recognizer spots on something that is not the target word. So there's an inverse relationship between these two error types, and there's a range of options on trade-offs. We call these operating points, and you'll want to choose an optimal operating point for your product. A more accepting or sensitive model will have lower FR, but potentially higher FA. And on the opposite end, a more discerning model will have lower FA, but could have higher FR. So typically we set the operating points to balance and minimize the number of overall errors, but different products benefit from different operating points. And testing is the way to find the optimal sensitivity for your product. So how to test. First, we'll need to have a large test set that ideally replicates the actual domain of your product. Testing a product that will be used in a hospital on, say, the beach might be enjoyable, but it won't tell you anything about how the model performs in the sound environment that actually matters. We also need to test on a large set of speakers from the target demographic, ideally. This helps us make accurate inferences about performance and helps us choose the optimal FR sensitivity for the most amount of people. Small sample sizes here could, for example, bias the model to speakers from one part of the target country. We run into this a lot. A lot of testing is done in what we call anecdotal settings in speech recognition, which often just finds the optimal FR rate for whoever is testing in your office, the 10 people around you. And it really can't give you an accurate prediction of performance in your product going forward. So yeah, testing for optimal FA and FR is really important and lends itself a lot to the user experience. Other factors I've included here is noise mitigation. This is using acoustic echo cancellation, beamforming, noise cancellation. Basically, make sure the sound that gets to your speech recognizer is good quality. We encounter the range of quality and noise mitigation tech in our lives every day, from talking on the phone, listening to music, to, as a bad example, trying to hear the next stop announced over a subway system intercom. This investment provides performance that is more accepting, but without increasing the rate of false accepts, FAs. The next decision point, ideally before development, is model size. So sensory really rocks here. Our models are usually embedded and pretty much all are very, very small and fast. That being said, there are still trade-offs between, say, an 80 kilobyte model and a 1 megabyte model. Larger sizes like 1 megabyte perform really well, but could add latency or overhead in your application. Smaller sizes tend to leave some FA, FR performance on the table, especially in noisier or novel environments. This leads me to my last point, which is the option to use revalidation in the cloud. You may be able to reap the benefits of both a small and large model. Smaller models will stay on device and can be set to be super accepting without impacting the FA rate. The larger model will do additional discernment in the cloud instead of on your device. So anyways, there's a lot to think about when choosing and optimizing Hotword technology. Hotword phrases, revalidation, model size, optimal FA and FR, noise mitigation. But luckily, Sensory makes it really easy to develop and test different options really quickly. So I'll hand it over to Jeff, who will show you this in action.
Cool. Thanks, Grace and Ember. I love talking about the freaking fricatives. I pretend to be a linguist all the time, and it's awesome to have teams and people like Ember and Grace who actually know what they're talking about. So we've had a lot of detailed discussion, and so what I want to do is show a couple of live demonstrations. And there's a lot of different ways that we can use wake words. We can add speaker verification to those wake words. So in fact, I was just talking with a customer yesterday. They're like, yep, we want a wake word, but we also want to know who's saying the wake word, because based on that, we can do different types of things in the product. So great. We can add speaker verification. We can add speaker identification, and those are slightly different. Verification is more about, I want to make sure it's the actual user saying the wake word, whereas identification is, I don't really care so much about the differences between the people, but it'd be nice to know who's saying the wake word. Example would be, when I say a wake word to a TV, I'd love to see my home screen. I don't need to see my wife's home screen or the kid's home screen. I want to see my home screen. And so identification would be great there. User-defined wake words is also really interesting. This is where the user gets to pick their own wake word. They can, this works in any language and with anyone's voice around the world. Also talking about multiple hot words and phrases where these could run, where we could run multiple wake words at the same time. And Sensory can be the arbitrator between which cloud engine you want to go to, or whether it's a cloud engine or an on-device, as an example. As well as what I call software-driven events, where something happens in the product, which then queues up, hey, listen for these two wake words. And I'll show you an example of that as well. And then, of course, many of you are familiar with our Voice Hub tool. It's an amazing new tool. It's actually not so new anymore. It's a couple of years old, but we've got literally thousands of developers and companies that are using it today to create your own custom wake words and phrase spotted command sets. And I'll show a quick example of that. And then finally, tying in with the video that Todd shared at the beginning, I want to show how we can tie our wake word into something real like ChatGPT. So Amanda, if I can grab the screen from you, let me start with our speaker verification and identification. So what you can see here is this is just my phone, and I'm just screen sharing my phone. And I'll hit enroll here. You can see three different types here. The first one's an enrolled fixed wake word, where I have to say Voice Genie, and then it also combines our truly secure speaker verification, or we call it TSSV because we love acronyms. The other is a user-defined wake word that's using truly hands-free and truly secure speaker verification. So you can kind of get, hey, I want the wake word to be always on and listening, and then I want to confirm who's speaking with the TSSV algorithm. Or the third one is just a user-defined wake word with truly hands-free only. So I'm going to select the middle one here. And so here I can just say, I can just type in my name, and then I'm going to press start. And now, because it's user-defined, I can say anything I want to. So I'm going to use my webinar as the wake word. So I'll click OK, and then it's going to ask me to say it 4 different times. And so anyone that has an iPhone, you're very familiar with this process. You get a new iPhone, and it has you say, hey, Siri, 6 different times. Our enrollment's 4 times. So you'll kind of see this, the pace that we can go through this at. My webinar. My webinar. My webinar. My webinar. So that's the whole enrollment process, super, super fast, as you saw. And now this is me, the enrolled person. So if I go to the spotter screen, and sorry, I made the screen larger so you can hopefully see it better, so the text is a little bit off here. But so here's me. And then if I go to the threshold window, this is pretty interesting. So the first one here is truly hands-free recognition. This is basically, was the wake word said yes or no? And you can see I can move this slider to be more accepting or more rejecting. So I have a level of setting there by itself. Next, I have truly hands-free speaker verification. And again, I can adjust this to be more accepting, looser threshold, or more rejecting, a higher security. And then finally, I've got the TSSV, or truly secure speaker verification algorithm, which again has a slider. So right now, I have all these pretty accepting. And it really can be up to the OEM, or you can expose it to the end user to pick, hey, in my situation, I need this level of security. So as an example, if I were using this in a home panel in my house, I'm not that afraid that somebody's going to break into my house and know what my password is. And I'm not concerned that my neighbors are going to use their key to my house and get in and change things around. So I'd probably have it be more accepting so I can reduce the chance for false rejects, which is a situation where I say the wake word and the password and nothing happens. So again, this is all adjustable. So I'll just click OK on this and then start listening. So you can see the green line bouncing here. So it's listening for me to say my webinar. And when I say that, it's going to say it spotted me saying the wake word, it passed speaker, the truly hands-free verification, as well as the TSSV verification. And you notice that I can say my webinar in the middle of a sentence. And because of our truly hands-free wake word, it's spotting. And so even though I have that other noise in the background, it still recognizes it. Now we could try, actually, I'll put my phone close to the speaker and I can have Todd, I'll ask Todd to say my wake word. And what you'll probably notice is that it'll come up as a red box and you'll see that it'll probably pass the wake word is recognized, and THF will probably also pass, but TSSV most likely will reject it because Todd's voice is not my voice. So Todd, you want to give it a try?
Sure, I'll give it a try. Let's see what happens when I say my webinar. My webinar. My webinar.
So I don't know if Zoom is killing it, but when I say my webinar, of course, it's going to spot it every single time. And so again, all these settings are adjustable based on kind of the use case that you need. Okay, so let me pop out of this one and share another screen here. And this is our Voice Hub. And I'm going to share my whole entire screen here. Okay, and I made it larger, so hopefully you can see this. So this is what Voice Hub looks like, and this is a wake word project. So here I can name it whatever I want to here, and then down here I can pick the SDK version. I can pick the size that I want. You can see that we can start at 80 KB. We can go up to about a megabyte. I can pick the language that I want. So I'm using US English for this demo, and you can see that there's a lot of different languages that are supported in Voice Hub already. I'll just stick with US English. And then the output format, in this case, I'm just using our standard SDK, but you can see that there's a lot of different formats that are supported. And these are kind of generic formats. So our newest one is our M55, U55 here. And you can also see some generic ones here for hi-fis and Cortex M3s and 4s and 0s and other things that we can select. You can see there's two options here for performance: prototype and then best quality. So prototype basically means I want to kind of consider the options for my wake words. What are they going to be? This will build much faster. And then when I'm ready to actually try something for testing and even for production, then I can use the best quality. We do have, I think there's 5 or 6 customers that are now shipping products on the market today that have used Voice Hub for their output. Now, sometimes customers will say, hey, I want even better performance. Great, we can always hand tune models, and that's what Ember and Grace's team can work on here. But for this one, let's just use Voice Hub. So here I can type in whatever I want. So I can type in, hey, Siri, as an example. I hit return, it bounces down to the next one, and then Alexa, and then also, hey, Pi. Todd talked about the app Pi, and I use that app as well. So here I've typed these in. And then you'll notice there's a speaker icon over here that basically will play back what the recognizer is expecting. So you can do a little bit of development on your own. So as an example, if I typed in HBO without any spaces or periods, it would play back a file that sounds like hobo because it thinks that's what I'm doing. And so, oh, no, that's not what I want. So I put some spaces or periods in it, and then it's going to come back and say HBO. So once I'm done, I just hit build. And a set like this, and this is multi-wake word set. And a set like this is probably going to take an hour or two to build. And so to save time, I've already built it here. And so here are my 3 options that I typed in. And then I can download and test the file immediately. So then if I go to I've got an application on my phone called Voice Hub. And that's here now running. So I can download the model. And then using my phone, I can scan this QR code. So I hit scan the QR code, hold my phone up, scans it in, loads it in immediately. So it's really slick and easy to use. And now these wake words are on and listening always. So I can say, hey, Siri, and it's going to recognize that. Or I can say, hey, Pi, if I want to talk to Pi instead. Or I can just say, Alexa, and it's going to go to that one instead. So again, Sensory can be the arbitrator. We're doing this in automotive today, where the automotive OEMs are like, well, I don't want to put everything on Apple or on Amazon. I want to support all of them as an example. Great, no problem. So this is an example of running multiple wake words at the same time. Now, I also mentioned that we can do things like what I call a software-driven event. So this is a great example: answer call, ignore call. I'm in the car driving along. I don't have to say, hey, wake word, answer call. It's too much. We can just load this set in based on the fact that there's an incoming call. So again, I can download this model into my little app here, and I'll scan the QR code. This is so slick. I honestly, I don't know how we did business before we had this tool, because now it's so easy to do these things and do kind of quick testing. So now this is a multi-wake word set listening. So a call comes in and I just simply say answer call. I don't have to say, hey, wake word, answer call, or I can say ignore call, and it's just going to ignore the call. So again, these are what I call software-driven events. Okay, so lastly, I talked about the fact that we can interface with these LLMs like ChatGPT. So here's an example of a wake word that was created, and here you can see that it was phonetically typed in. So it's GPT. The other way I could have done this is I could have just done G period P period T period, or spaces between them, and it probably would have come out the same way. So here I've got this wake word, and then I've got another app that we've created that's called Sensory Chat. So let me show you that demo here. Okay, so here's Sensory Chat. And what Sensory Chat is this is where the wake word is running local, and our new truly natural speech to text is also running local. So as Todd said, we can send so much less data, so it's less expensive, less time consuming. I don't have to have the same signal strength to send I'm just sending the text to, in this case, ChatGPT. It could be any LM. So here you can see that the default wake word is our standard one here. Well, I just created this model here, so I'm going to download this model. And I'm going to go into settings, and I'm going to hit the QR code here. Did it do it? It did it. I'm going to select that one. Okay. Okay, so now you can see I've got the wake word running here. So now I can just say, oh, and by the way, I created my own little demo for Home Assistant. I basically did a little prompt engineering where I said, okay, you're a home assistant. You're going to control devices around the home. You'll respond with intents and entities. So now, using the power of an LLM like ChatGPT, I can say, well, you can see that it recognized it right there. So I'll stop.
I can assist with controlling devices in your home. How can I help you today?
Hey, ChatGPT. I want to turn on the bedroom lights, I want to close the garage door, and I want to set the temperature in the kitchen to 68 degrees.
Intent, turn on bedroom lights. Entities, bedroom lights. Intent, close garage door. Entities, garage door. Intent, set temperature in kitchen to 68 degrees. Entities, kitchen temperature, 68 degrees.
So it's amazing. And now, unlike the video that Todd started out with, I can be talking and the LLM is not listening to me. It waits until I say, hey, ChatGPT, open the blinds.
Intent, open blinds. Entities, blinds.
Amazing. So all of this is all possible with Sensory wake word technology, and where we can do, we can add speaker verification, we can do speaker identification, we can allow the user to pick their own wake word. And then we can also tie in, we can be the arbitrator where we can go to different cloud solutions or on-device solutions. And then the last demo here that I just showed is super, super interesting, because we're actually running the wake word, we're running the speech to text, we're doing it all locally, and then just sending that text information. I'll turn it back over to Todd.
Thank you, Jeff. And thank you all for sitting through this. Sometimes I go to webinars and I leave after a minute, and I've been kind of watching the attendee count here, and you guys are sticking with us, so I appreciate it. This is our last slide. After this, we'll have Q&A, so if you haven't sent any questions in, go ahead and send them in, and we'll spend a little time talking about things. I want to briefly hit on the future of wake words for LLMs and voice assistants. And the future of the wake word is really closely tied with the future of the voice assistant. And voice assistants are going to become a whole lot more prevalent thanks to the power of large language models. They're getting more and more useful. Today, they're very conversational. Tomorrow, they're going to be very action oriented so they can do things for us. And they're going to have memories, and we're going to be able to give them custom names like Jeff showed. And one thing that's going to really change is they're going to follow us from product to product. Right now, I might use my Alexa device, and it knows all about my favorite music choices, but that's all it knows about me. And there's a whole lot more it could know. When I go into Amazon, for example, Prime, it knows my shoe size. It knows my that I always buy running shoes. And when I go into Google Maps, I always look for vegetarian restaurants when I'm looking for a restaurant, because I'm a vegetarian. So each of these separate apps and separate companies have this information about me that they've stored. But what's going to happen in the future is our personal assistant is going to be sort of a private assistant for us that knows all of these things and can help us in all these things, so that if I'm getting a free personal assistant and I have to get ads, well, they're going to be ads for the shoes that I want in the vegetarian restaurants that I like to frequent. So what's going to happen with the wake words that go with these? Just like the personal assistants, the wake words are going to get better and better. And we've already talked about some of the ways that they will improve. We're going to have wake words that can sometimes be on and will sometimes be off. So Jeff gave some interesting examples of how, like, an incoming call can trigger a wake word to start up. In a wearable device where the battery technology hasn't really kept up with all the other technologies going into it, you want to be very conservative of power. So it might make sense to only turn on wake word or command sets at certain moments. And we're making it easier and easier to do that with intelligently thinking about when things should come on and off. We have this intelligent thresholding that goes with our smart wake words. And I think Grace talked a little bit about the power of thresholding. And actually, Jeff showed you that in some of the sliders where you could manually slide those things. We're coming up with algorithms that automatically move those sliders around. So if you're in a noisier environment, it might make the wake word a little more accepting. If you have a strong accent, it will adapt to that and get better and better at understanding you and your voice. And as Jeff showed, we can have speaker verification built in there too, so that if we have shared hardware devices, I've got a bunch of Echoes in my house, and we talk to it, different people talk to it. It'll know about me and know about my wife in a different way, a different set of information about each of us. Just like in the example of the television that we talked about earlier, where you don't have to go in and choose who you are. It just knows who you are by your talking to it. Grace talked a little bit about the power of revalidation, and Sensory's always been doing this with really tiny models that run below the OS, and then bigger models in the operating system. With the large language models are going to be really, really good at understanding intentions, and that will make them better and better at throwing out things that they thought might have been wake words if the proper intent doesn't follow it. So we're going to see less and less kind of errors, more and more usefulness in our assistants, and more combinations of sensors with the voice assistants, cameras and IR. They're going to be looking at us and understanding better. And if you think about it, it's really just going to be like we communicate with each other. When I'm talking with Jeff, I might single him out and say, hey, Jeff, this, but I don't say it every time I talk to him. I can do things like looking at him, and my gaze helps direct who I'm talking to. So things are going to it's getting better all the time. The Beatles, things are going to get better and better with large language models and the wake words. And I think we're going to move on to Q&A.
Thanks, Todd. Okay, I'm going to stop my screen share here so that we can see all of our lovely panelists. And we've got a handful of questions coming in, both in the Q&A and the chat, so I'll try to get to all of these. Let's see here. First up, for the same system, can the user set different thresholds for different applications?
Yes, that's basically an application design.
And is the ASR an embedded one?
Yes. Yeah, we have different sizes that we can run embedded. In general, the smaller the size, you're going to get a little bit worse accuracy. And there could be, some interesting trade-offs, because actually some of the things we do to get smaller require more MIPS and more power because of the decompression techniques we're using. So in a lot of ways, like with wake words, as they get smaller and smaller, they usually use less power. But with our speech to text technology and our NLU, it doesn't necessarily work that way.
Thanks, Todd. Jeff, you might want to unmute.
You can't read my lips? Come on, Amanda. I was just saying that every demo that I showed today, from the sensory perspective, ran 100% local on my phone. The only one that actually went to the cloud was the last one with the ChatGPT. So the wake word was local, the speech to text was local. Then I just sent the text off to ChatGPT for the interaction there.
All right, thanks, Jeff. Let's see here. How can I integrate this using Flutter?
I saw that question and I immediately reached out to my FAE and said, "What the heck is Flutter?" And he said, "I'm not sure on that one." And so I reached out to our apps guy and said, "Hey, what do you know about Flutter?" So sorry, I don't know. I don't have an answer for Flutter on that one. We'll have to get back to you on that question.
No worries, Jeff. Closely related. What low power platforms can Sensory run on?
Great question. So we run across more than 20 or 30 different low power platforms. So we can run on something as simple as a really simple DSP to something that's M33 based, M0 based, M4 based, M7 based, A53, kind of a full application processor. So really across the board, and within VoiceHub, there's a lot of different, all those different options are available in there, where you can basically type something in, select the type of platform based on the format that you're using, and then VoiceHub's going to create to that format, and it should run directly on those different platforms. So again, more than 20 different platforms.
Okay, got a couple more here. Can you talk a bit about the answer and reject calls?
Sure. So what I was demonstrating there was the concept of I'm in the car, I'm driving along, a phone call comes in, the head unit understands that, the Bluetooth protocols understand that, and that in itself in software could trigger, okay, listen for answer call, reject call. And the same thing
is that you can dynamically call up different sets based on environmental things that are going on. It saves power and it can improve accuracy.
Yeah, the car is just one example that it could be in a wearable. If I'm doing an exercise and then I stop, well, right now my watch basically pauses it and says, "Are you done with the activity?" And then I'm no. So here it could just pop up, or it could just start listening for a wake word that says, complete my run or complete my walk, as an example.
Okay, I'll keep firing away. Maybe a couple more minutes here. How well does VoiceHub work versus a hand-tuned model, and what is the cost difference?
Yeah, that's a good question. So everybody knows the expression garbage in, garbage out. Well, it certainly applies to model building as well. And if you think about it, VoiceHub has this really nice feature in that we've really thought through the data, and we use synthetic data. So we create our own data for VoiceHub. So it's never going to be garbage. You're always going to get a decent result from VoiceHub. But a hand-tuned model goes out and collects real-world data. So a hand-tuned model can be a lot better than a VoiceHub model if the data that we're collecting actually matches the real testing or usage. Testing should match the usage. It doesn't always. It's one of the big mistakes we see with our customers is they test a certain way and reach conclusions that don't match kind of how it will be used in the real world. It's really important if we're building a custom model for you that we get real world data. So we need to, Grace talked a lot about these things. We need to understand the preamp and kind of how the noise is being processed. We want to know the demographics of the user. So do they have accents? Is it, what gender is it? These kind of questions all play into building the best models. And the more we can replicate that data accurately in our training for a custom model, the better a custom model will work relative to VoiceHub. Cost-wise, I mean, Jeff can tell you the cost of a model better than but I tell people it's about 10K. I think foreign languages are a little more expensive because the data collection is more. VoiceHub right now is free, and we're even allowing trials of VoiceHub Pro right now. So at some point in the future, we're going to start charging. Now's a great time to sign up and get it for free.
Thanks, Todd. All right, we're right at time here. I do still see a handful of questions in the chat. I'll make sure that we follow up with you each individually to help answer these questions. Panelists, thank you for your time today. Everybody who attended, thank you. We'll send a follow-up email that has this recording so that you can watch it again. You can share with your colleagues. Thank you all.